In this video, we will be discussing a topic from set theory, and our aim and target will be to identify and describe mathematically different sets shaded in the Venn diagram using one universal set with two subsets. So basically, we are going to describe a Venn diagram, a shaded Venn diagram mathematically. Now, take an example. If this is a Venn diagram which is shaded, and if you observe which uh, which parts in the Venn diagram are shaded, then you will observe that this is suppose circle A, and this is circle B. Now, in this diagram, circle A is shaded completely, circle B is shaded completely, then we can denote it in mathematical notation as A union B, because complete circle of A as well as complete circle of B is shaded, and that is the case of union of A and B. Now in the second part, if you observe that we have a shaded section, and this shaded part is a part which is overlapping part of A and B, and if we denote this overlapping part as intersection of A and B, so we can name it as A intersection B. In the third problem, in the third case, we have shaded everything. We can observe that everything is shaded by the horizontal lines, but the circle A is not shaded. That means this Venn diagram represents a complement, because A is not shaded. Everything other than A outside the circle of A within the rectangle is shaded by these horizontal lines. In part 4 of this uh, worksheet, we can see that we have shaded everything with vertical lines other than the circle B. Now, if B is not shaded and everything outside B is shaded, that means this is complement of B, mean other than B everything is shaded. Now, if we have a look at this one, now in this part, A and B both are not shaded, and the region outside A and B is shaded using horizontal lines. So we can say that this shaded region represents A union B complement, which means not A union B. That means A union B is not included. The region outside A union B, which represents complement of A union B, is shaded. Similarly, this part and this part is quite the same. Basically, this shaded area can also be represented by a complement intersection B complement. As you know, A complement being the region other than the circle A. So we will be having this region in A complement in which you will not include A. This region will be included in A complement. And in B complement, B will not be shaded, and the region outside B, this one, will be shaded. And for intersection, we have to see the common area of A complement and B complement. So you will observe that this outside part is a part of A complement. This outside part is a part of A complement, and this part is also a part of B complement. So this area is common to both A complement and B complement, which means this shaded area is represented by A complement intersection B complement. Now in the next part, uh, if you see the shaded area, now this shaded area, basically it is representing a minus b. Actually, we have subtracted b from the circle of a. This part was also a part of b. So we have subtracted this part from the circle of a. So we can say that this is a minus b. Now considering this part, uh, this unshaded region is b minus a. This unshaded part which is not shaded. Now this shaded part is the complement of b minus a. In b minus a, we have subtracted the section of a which was basically overlapping with b. So this is b minus a. This part, this white part which is not shaded, is b minus a. However, we have to give the answer for this shaded area, and because this shaded area is other than this b minus a, hence this is b minus a complement. Now in this diagram, we have to answer the shaded area, and this represents b minus a, the part which is also a part of a. So b minus a will give you this shaded area. Now in this part, with the area shaded is basically p, the circle p, minus the circle q will give you this part as your answer. And in the last part, this one, now as you can observe that the shaded area is the area which does not include the circle of p. Basically, the circle of q is a part of circle of p, and the shaded area is actually outside the circle of p. Hence we can say that, and as we know that everything outside this circle p is p complement, so this shaded part is basically representing p complement. So this was a general discussion about how to answer and how to basically describe mathematically different sets shaded in the Venn diagram. So keep watching. Thank you so much.